install. We discuss about these various configuration files, and at the end we will install a single node Hadoop cluster. This is the agenda for today's session. Okay. So here, just a recap. Since we have this architecture associated with this Hadoop cluster, it's a master-slave architecture. So we have some computers which is coming under master computer, and some computers which is coming under this slave computer, which is a master-slave architecture. So here we have a computer called as a name node, which takes care of controlling the entire cluster. The name node will maintain the metadata. This is the entire master of the entire Hadoop cluster. And we have a secondary name node which supports the name node during its recovery phase by keeping the metadata information of the name node in its hard disk and supplying this metadata information whenever a new name node is up. So we have a job tracker. The role of job tracker is job execution that we have discussed in our session. So we need to configure this as a separate servers. We need to configure this as a separate servers. Similarly, we have data nodes, and data nodes also a separate machines. On top of the data nodes, we will be having running task trackers. The task trackers are nothing but daemons, background process that we are running on top of the data nodes. The task tracker will do the job execution according to the instruction and the program given by the job tracker. Okay, the job tracker is a master and task tracker is a slave. These are all the things that we have discussed. So in our Hadoop cluster, we want to establish all the above that name node, secondary name node, job tracker, data node, and task tracker. Okay, in terms of various types of clusters has been concerned. So here, based upon this number of data nodes, how many number of data nodes that we can have in our cluster? So here, the number of name nodes, the number of secondary name nodes, and number of job tracker, it is mandatory that you can have only one name node, only one secondary name node, or only one job tracker in terms of Hadoop own context. You can't have a two name node, you can't have a two job tracker. It is mandatory that you can have only one thing. But the number of data nodes, you may have n data nodes. Here, the n depends upon two factors. Number of data nodes depends upon two factors. One, the volume of data that you are going to store. Second, the hard disk capacity of your data. Hard disk capacity of your data. These are all the two factors that is going to decide the number of data nodes in your cluster. For example, so here, if you want to store 10 TB of data, this is your data size. Let me take a file.text whose size is 10 TB. So here assume that you have a data node, the hard disk capacity is of 2 TB instance. The number of data nodes here in this case is to store this 10 TB. Being the capacity is 2 TB, we need 5 data nodes. Okay, 2 into 5, it will result in the 10 TB of storage. What happens, imagine this 10 TB, how it is stored, as we have already discussed. Imagine you have 5 data nodes, and each data node will have a 2 TB, 2 TB each. The data node, being it is made up of a commodity hardware, advantage of going for Hadoop is it is made up of commodity hardware, that is a low cost hardware. So there is a probability that it may fail more frequently. It may fail more frequently. Imagine this 10 TB of data containing 1 crore of transaction data. So each 2 TB is assumed to be 20 lakhs, 20 lakhs. If this data node went down, what happens in this case? So you may lose this 2 lakhs, 20 lakhs of data. For that purpose, it is recommended to go for a replica. Okay, you need to go for the data will be stored in a block, and blocks will be replicated across 3 locations. Therefore, if we take into consideration 3 times that we need to replicate instance, 3 replica for each block instance, the total storage space needed is 30 terabyte. So with the data node size of 15 terabyte, if you follow the replica concept, you need 15 data nodes. Am I making sense? So according to the number of replica, you also, this factor also have an influence. So in some case, you may feel your data needs to be more secure. Instead of having 3 replica, if you are interested in having 5 replica, yes, that is possible. If that is the case, 10 TB into 5 replicas equal to, you want to store 50 TB. So since you have 2 TB of storage space, therefore you need 25 data points. So these are all the factors. The third factor is the replica, number of replica. So no, it is a 2 is enough for me. Yes, that is possible. No, I need only 1. That is also possible. So, but Hadoop recommends to have minimum 3 replica. If you want to overwrite the default value of 3, yes, that is possible. For that, what you need to do, you want to put an entry in a file called as hdfs-site.xml. We will discuss the thing during our installation part. You just make a note of this part. This is the interview question appeared for an architect. If you want to change the number of replica, then you need to change. Okay, the number of replica is not mandatorily need to be 3. It is a recommended thing. You can either increase or you can either decrease. If you want accordingly, you need to put an entry in a parameter under the file hdfs-site.xml. Okay, so you know aware of how many data nodes that you need to have in your Hadoop cluster. Then that depends upon the following 3 criteria. Okay, now we are going to discuss about these various types. So in terms of the number of data nodes has been concerned, based upon the number of data nodes in your cluster, we can categorize into 3 types of Hadoop cluster. One is a small cluster. Second one is a medium cluster. Third one is a enterprise cluster. A small cluster may have up to hundreds of data nodes. Tens to hundreds of data nodes constitute a small cluster. So up to thousands, hundreds to thousands will form a medium cluster. Beyond 1000 will form an enterprise level cluster. Okay. Today's largest cluster is managed by Yahoo. It is running in terms of roughly 60,000 plus data nodes. Okay. All these data nodes will be managed by multiple name node servers. That we will discuss that scenario of Yahoo and higher enterprise level scenario in our discussions. It will be helpful for you while appearing for interview. Okay. So here, if it is a small cluster, so here the reason, the advantage of going for this Hadoop, 2 advantage. So before Hadoop, why we need Hadoop? We have initially discussed about these RDBMS tools like Oracle and the limitations of these RDBMS tools. So why we can't make use of this RDBMS tool for storing big data is because of its limitation, because of its centralized database architecture, a single server architecture like this. So we go for a solution by name Hadoop. So whether there exists any other solution apart from Hadoop? Yes, we have a solution in form of big data appliances. You may have heard about this data appliance. It is nothing but a combination of sophisticated hardware plus customized software. We have a combination of sophisticated hardware plus a customized software. Okay. So you may have a higher end service. You may have heard about this Teradata. You may have heard about this Exadata, Greenplum, IBM's Netisa, all those things. These are all examples of data appliances. So here, these data appliances can able to support the storage and processing of what we call the big data. Okay, let me look into the data appliance. So here they may incorporate it with very sophisticated, you can find it has a support for NoSQL database, Hadoop. Okay, it have connectors, everything. It is a sophisticated server. These are all sophisticated servers, a higher-end server with a huge storage capacity, with multiple processing units. It can support storage and scalability in terms of petabytes, terabytes, and petabytes. So, what are all the characteristics associated with big data in terms of the data types, structure, semi-structure, unstructured, huge volume, generating with very high velocity, containing lot of anomalies. All those things can be stored and processed by using what we call the data appliance. But the drawback here associated with this data appliances is cost. Here, in terms of cost, you need to invest in terms of 30 to 50 lakhs of rupees to procure this hardware. Such a huge cost hardware. All the softwares associated with the data storage and processing are licensed softwares. Okay, you need to pay for license. You need to invest a huge amount for investing for this infrastructure. Okay, these are all the drawbacks associated with the data appliances. So nowadays, if you look into countries like India, they have a lot of startups. They have a lot of mid-level companies, entry-level companies. If you took consider 100 companies, nearly 70% of companies are coming under entry-level companies. For them, it is not possible for them to have this much of huge investment in terms of 40, 50 lakhs to procure the infrastructure alone. They may have very limited amount and they can't, it is not affordable for them to invest this much of amount. But they have a data, the data of caliber of big data, and they need a solution to do processing and do analytics on top of it. But the existing solution of data appliances is not affordable because of its high cost. Then here comes a solution from the Apache Open Source Foundation. The Apache Open Source Foundation developed a framework called as Hadoop. Hadoop, we call this Hadoop as a framework. Okay? It is a combination of several components, subcomponents. We have components for data crawling, such as scope, flow, kafka. We have components for data processing, such as Hive, Pig. We have frameworks like MapReduce, Spark. We have data storage, such as HDFS, HBase, and we have data management. We have Zookeeper. We have a scheduler by means of Uzi. We have a graphical user interface by means of Amari. So these are all several constituent components of the Hadoop framework. Using all the above said components, we can crawl, we can store, we can process on top of it, we can store the data, what we call as big data, with very, very less cost. That's the advantage. This Hadoop framework, which was developed by Apache Open Source, it's an open source framework. You no need to pay for anything. It is an open source. What are all the tools that we are
Raman.
The above tools for data storage, processing, data crawling, all the tools are free and open source. You no need to pay for anything. And in terms of hardware has been concerned, you no need to go for this high-end servers. Okay, this is a sophisticated server. You need servers, but not as sophisticated as that we are going to work with this data appliances. So what I need, you can build a cluster with a commodity hardware. What do you mean by commodity hardware? The commodity hardware is one which consists of low-cost hardware. You can build a cluster using i3, i5, or i7 like machines. Okay, so as I told, here you have a master and you have a slave. Can I make use of the commodity hardware for both master as well as slave? The answer is no. For data nodes, you may have using this commodity hardware. Okay, for your master, if you use this commodity hardware for name node, imagine the commodity hardware being there is a huge probability of subjected to frequent failure. What happens if a master file? If you have 100 data nodes, if your data node contains 2 files, no matter. Why so? Because being your data is replicated across other 2 nodes, it won't have an influence here. You can able to read or write the data from the remaining 2 nodes if your data node fails. But what happens if the name node fails? Or what happens if your job tracker fails? You can't do any activity if a name node fails. So if you have a commodity hardware for a name node or job tracker, And if those hardware being, it is a huge probability of subjected to frequent failures. If it fails, what happens there in this case is the entire cluster will down. Therefore, going up with this commodity hardware is not recommended for our masters. For masters, you need to go up with a little bit high-end hardware. Okay, you need to go up with a little bit high-end server, and for slave, you need to go up with this commodity hardware. Please make a note of these things. In a real world, we make use of I handled clusters while providing training. I handled clusters of size 50 node cluster, 100 node cluster. So the configuration for those sort of environment, I had provided training for TCS, Informatica, okay, recently, and for Tech Mahindra also I provide training, okay. So here in this environment, the number of nodes of data nodes are 50 or hundreds in numbers. The configuration here they make use of this i7 with 32 GB of RAM. Okay, with 4 TB of storage hard disk for your slaves. Here's Intel Xeon dual core. In some case, Intel Xeon dual core with 32 GB of RAM. Minimum recommended RAM is 32 GB. So if they go with a framework called as Spark, under the circumstances, it is recommended to go up with minimum 64 GB. We will have a discussion on Spark in the course later. Okay. So for your servers, it is recommended to go for Intel Xeon, minimum 6 core or 8 core or 12 core servers. And the RAM memory here needs to be minimum of 128 GB or 64 GB. 64 is minimum. Okay, these are all the server architecture. So whether it is a name node or it is a job tracker, the server comes with Intel Xeon, the above set code, and with the following. The hard disk capacity here will be very, very minimum. 2 TB is sufficient. Okay, 2 terabyte of hard disk is sufficient enough. But the RAM memory need to be more in your servers. Hard disk need not to be more in server. The hard disk capacity need to be more in your slave nodes. Also because the data storage and data processing, the storing of data, the data storage and the processing of data will take place only on the slave nodes only, not on the masters. The master node, why you need a more amount of RAM memory in your master? Because the master is going to maintain the metadata information about all the data nodes in the cluster. It needs a huge storage capacity in terms of RAM. You just make it, these are all the requests. You please make a note of all those. You need to have, in terms of this hardware has been concerned, RAM capacity need to be more in master, hard disk capacity need to be more in data nodes because of the opposite reason.
Sir, Raman sir, one quick question. RAM should be more in name node. Is that what you're saying? Hello, Raman sir, can you hear me?
Okay.
Hello.
This basic introduction. Let me move further. So, in terms of your cluster, as I already discussed, there are 3 types: a small cluster, a medium cluster, and an enterprise cluster.
Raman sir, can you hear me? This is Sundar.
In a small cluster, imagine you have up to 10 to 100 data nodes. In this case, you can have one master, one computer designated as name node, and the job tracker can be defined here itself. And you have multiple data nodes here. Data node 1, data node 2 may have n data nodes. Here you can configure all the three: name node, job tracker, and secondary name. If it is set to hundreds in number, you can able to configure all the opposite master on a single server, and these are all slaves can be configured separately. Also, because being a less in number, a single server can able to do all the activity associated with the name node, job tracker, and secondary name. If it is a medium cluster, you can have one computer name node, and the job tracker can be configured on a single machine. The secondary name node need to be configured separately. You may have multiple data nodes. In enterprise cluster, we need to have a separate entity. A name node as a separate entity. A secondary name node as a separate entity. A job tracker as a separate entity, and all the remaining data nodes. Okay. So this why to it is this is mandatory that if the number of clusters is within 10 to 20 or 30, all the things need to be configured on the same master. No, for cost cut, this is sufficient enough. So no, I need to have a separate name node. Doesn't matter. Cost is not bad for me. I need to have a separate name node. I need to have a separate secondary name node. I need to have a separate job tracker. Yes, that is possible. So, but it is not at all needed. Since the number of data nodes is minimum, a single server can have the capability of handling a name node, job tracker, and secondary name node functionality single-handedly. So that is the recommendation. So these are all why the advantage here is if you go for a higher-end server, a server may cost around 3 to 4 lakhs. So if it is if you want to purchase 3 servers, imagine if it is 4 lakh, you need to invest 12 lakhs. So instead of that, if we can able to achieve within 4 lakhs, 8 lakhs, we can able to save. That is the reason why we need to go for with the following architecture. Please make a note of this. It is not mandatory, but it is recommended. Then it is the best practice to going up with. For example, several companies for doing use cases, they make use of a single server and a number of data nodes. For real time only, they make use of the opposite environment, a separate server for name node, job tracker, and secondary name node. For use case related activity, everything can be clubbed on a single server.
Sir, Raman sir, this Sundar, I have a question.
So the advantage here is you can able to minimize the cost to greatest.
Raman sir, can you hear me? Hello, Raman sir, can you hear me?
Now we are going to discuss about various modes of configuring a Hadoop cluster. There are basically 2 modes. One is a single node cluster, a multi-node cluster. Under multi-node, we have 2 subcategories. Pseudo distributed cluster, fully distributed cluster. A single node is one under which with a single computer will be configured same node, secondary name node, job tracker, data node, and task tracker. All these 5 daemons will be running on a single computer. So this is for learning purpose, not for real-time implementation. It is for learning purpose. In a multi-node cluster, you have a pseudo-distributed cluster. Here too, you have a single node, but they are run separately. Each and every, they will be running separately on a separate VMP. A separate Java virtual machine may have a name node, may have a secondary name node, may have a data node. But here you will be having a single node only. So here you make use of this virtualization software or any other thing to run as a separate JVM. Whereas a fully distributed cluster, each and every machine is a physical computer. You may have a separate name node, you may have a separate secondary name node, you may have a separate stop tracker, you may have separate data nodes. They are all physical computers. So these are all the ways by which you can differentiate a pseudo distributed and a fully distributed cluster. The pseudo distributed, each and every demands, we call name node, secondary name node, stop tracker and data node as a demands and as a separate JVM. Whereas in a single node, everything will run under a single JVM, Java Virtual Machine. You can't make use of a single node cluster for your production. For your production, you will be going up with a fully distributed cluster under which those nodes may be physical nodes, or you can take these nodes from a cloud, a public cloud like Amazon. Okay, this is the way by which you can configure in terms of the number of outputs has been confirmed. And with respect to the various technologies by which you can configure the cluster, you can configure a physical cluster. All the computers are physical computers. You can configure using this virtualization software. Here we can make use of VMware. We can make use of this virtual box. We make use of this Hyper-V, Microsoft Hyper-V. We make use of this Citrix. Okay. So our curriculum is going to deal with VMware workstation. Or you can make use of virtual box. So here we are going to make use of either version 11 or version 12 for our practice. So I will share you where to get this total and the key that we need to work with. I also share you both the keys, crack the key and where to download this substation. Okay. So this is the way here in this using this virtualization using this virtualization software, we can configure the cluster. Third thing, we can make use of this cloud, a public cloud or a private cloud. So if it is cloud, you can make use of two ways. One, by using infrastructure as a service, and second, by using Hadoop as a service. So here in Amazon, we are going to make use of this EC2, Elastic Compute Cloud, or infrastructure as a service, and we are going to make use of a concept called EMR, Elastic MapReduce, which covers Hadoop as a service. Okay, so here, what is the difference between using infrastructure and Hadoop as a service? Here, everything that you need to configure, you will be getting only machine only. The machine will be, you will need to install each and every activity that you need to do in a physical cluster. Whereas in EMR, all are pre-configured. What are all the things that you are needed, starting from operating systems up to all the tools that you need to configure with your Hadoop comes pre-configured. You need to specify only the hardware configuration of the computers and number of data nodes only. Everything will be pre-configured. And the fourth way is you can go for distribution, Hadoop distribution. We have several distributions, out of which Cloudera, Shortenworks, MapR, EMR is one distribution, Elastic MapReduce by Amazon, HV Insights, okay, HV Insights by Microsoft. These are all several distributions. So you know what is distribution. Okay, so for analogy, let me take Linux is the open source. So Ubuntu, Sen, Red Hat are all distributions of Linux. Okay, Linux is the open source. You can download the open source and you can add some new features to facilitate easy user interaction on top of it, and you can release under your own name. Okay, so these are all called distributions. Similarly, this Hadoop, it was open source developed by the Apache community. So several companies have taken the open source and they added some new features on top of it. and they release as the following distributions: Cloudera, Hortonworks. These are all some distributions. Under the distributions, almost 80 to 85% are common thing. Only 15% they may have some new features through which the user interaction, the user administration and management of clusters and all other activity has been simplified. So here they will provide those distributions as a fully configured machine. They will install each and everything and provide to you as a virtual machine. What you need to do, you want to simply download the machine and you want to run the machine. That's all. You don't need to do any other activity apart from that. But if you go with this Hadoop open source, you need to download and you need to configure each and everything on top of it. So these are all the ways by which as an administrator, as an architect, it is best suited to work with this open source Hadoop. If you are opting for developer alone, if you are not opting for any other thing, then you can go with these distributions. Okay, but the limitation in terms of distribution is, even though it is open source, for certain advanced features, you need to purchase, you need to pay for the distribution. Not all the features comes free with the distributions. Certain features is limited for payment purpose. So these are all the ways. But as an administrator, if you work with distributions alone, who doesn't know what is happening inside. So if you want to, you should have a aim to become an architect. A guy with 5 to 10 years of experience may be deputed as an architect, whether he is a developer or whether he is an administrator. The next moment will be an architect. For an architect, you need to know the nook and corner of the Hadoop. Not only in developer perspective, but also in admin perspective, but also in the underlying principles, everything an architect needs to know. Then only based upon this requirement, he can able to draft a solution. That is not in our curriculum. Okay, it not only covers admin, it also covers additional developer, and for developer it will be covered as some additional administration also. Okay, so here now we are going to discuss about how to make use of this virtualization software to configure a single node.
Raman sir.
To know one thing.
Sir, this is Archana.
This virtualization technology.
Sir.
All right. Now.
Raman sir.
So we have discussed about the various types of Hadoop cluster, small cluster, medium cluster, enterprise cluster, based upon number of data nodes. We have discussed about various ways of installing our Hadoop cluster, either a physical cluster or a cluster using virtualization, or we can make use of a cloud. And we have discussed about the hardware and software requirements in terms of hardware for server and for master and slaves. What are all the hardware that we are in need of? And now we are going to discuss about this installation part of a Hadoop cluster. Okay, so being it is a master-slave architecture, well, and it involves 4 computers. One computer name node, another computer secondary name node, the third computer job tracker, and we have multiple data. You may have a doubt in your mind whether you need to configure a sequence of software separately. Each and every system need to configure a separate software or not. So here, in case of your RDBMS, your server need to be configured as separate software, and your front end, your client need to be configured with separate softwares. The servers will be configured with separate softwares, the back end, and your front end will be configured with a separate. Similarly, whether you need to have a separate software for the opposite masters and data node, the answer is no. Whether it is a master or it is a slave. It's a list of process, the activity that you need to perform to configuration, and the tools that you are going to use is no way different. Everything is same. How it differs? That this machine is a master, that machine is a slave. Only based upon certain configuration parameters that you are going to enforce on it, it will differ. Okay, it won't differ by software. So what are all the things that we need to do for a master need to be repeated for all other machines. So we can decide whether this machine need to act as a master or this machine need to act as a slave by specifying the appropriate value in the configuration parameters of the aforesaid machine. Okay, once our discussion has over, you have a clear understanding. So what we are going to do in our practical, first we are going to create a virtual machine. And at the time of creating the virtual machine, you need to choose your operating system. Here I am going up with this Ubuntu. Either a 14.04 or it is a 16.04 LTS version. You want to create a VM. Else, if it is a physical server with Ubuntu, that is enough. Both thing works fine. If you have a machine containing Ubuntu, it is sufficient enough. Can you configure? Did you configure only based upon Ubuntu? The answer is no. You can make use of any Linux, CentOS, whether any OS is Linux OS is possible. But I am going up with this Ubuntu. Okay. Next step 2. So after that, the operating system that we are going to make out for is the Linux operating system, more specifically Ubuntu. Next, you need to make an update to the repository so that this update to the repository will result in update of the needed patches and the corresponding dependent packages for our requirement. It is a best practice to go for executing an update command so that all the patches and package and security related updates will be done on your machine. When you issue an update, this is your server, local machine where you are going to configure Hadoop. This is your Ubuntu repository, Ubuntu server. So this update command will let us do all the patches and dependent packages related updates from this Ubuntu repository down to our local PC. Okay, this is the way by which you can work with this update. And that's it. After that, you need to install Java. Step 3, you need to install Java. It is recommended to go for JDK 1.7 and above. It is recommended to go for JDK 1.7 and above. Okay. So next, you need to install SSK server. SSK stands for Secure Server. To facilitate, this is your PC. Here, to facilitate a secure communication between these two end systems, between a user and a computer, or between a computer and a user, we go for these SSKs. You need to install and configure SSKs. Then step 5. To authenticate you as a legitimate user, you need to go up with this key generation, SSK-key. It will generate 2 keys. One is public key, another one is private key. Imagine a locker, a bank locker containing 2 keys for your locker. One key will be kept with the manager, and another key will be given to the user. When you open this locker, or when you want to access something from your locker, both the keys need to be inserted. The key retained by the manager is assumed to be public key, and the key retained by the user is assumed to be private key. Okay? So here, the private key, the user will be considered as a legitimate user if he possesses the private key. If the private key is with a particular person, that person may be treated as a legitimate authorized user. Similarly, here too, so you may have multiple machines, a name node, a secondary name node. So while start the machine or while start the server, the user need authentication. Whether he is an authorized user to start, whether he is authorized user to start like the, if you are going to execute any activity, if you are going to run any job, we need to be authenticated. For that, this SSH key generation will be used. During this installation procedure, you will have a clear idea of what we can do with SSH key. Step 6. Okay, SSH key, a public private key. And using this, the reason behind that going for SSH key is to make to as a authorized authenticator legitimate user. And now next you need to download and configure Hadoop. You need to download and configure Hadoop. You can download Hadoop from the following location. You can go with this Google and you can download Hadoop from the following location. This is an open source Apache site. Download hadoop.apache.org.releases. You can connect with this location. So here these are all the current version 3. Now you can release. If you are going up with this older version, you click on this mirror site. Under mirror site, you can go slightly here. And these are all the distribution. For example, we are going to work with initially Hadoop 1.2. So Hadoop 1.2.1, and this is the file that you are in need of. It is a tape archive zip file, Hadoop tar.gz. It is a archive zip file. You need to download this file. Okay, it's just a 61 MB file. So if it is a Hadoop, you are looking for Hadoop 2.x. Now for that, these are all the 2.x versions. You start with the 2.6 up to 2.8. You can go up with any version. So 2.6. Here too, you will be having this file. Okay, 186 MB. This file Hadoop 2.6.2 .gz. Just to make a note of all those informations. You need to download whether it is 1 or whether it is 2. Accordingly, you need to download. Okay. If it is a Hadoop 3, then you need to, these are all alpha version. It is not yet stable. It may contain some issues. This is the file that you need to download. Hadoop 3 may have a more features. We will have a separate discussion on the difference between Hadoop 1, Hadoop 2 and Hadoop 3. Then you may aware of what are all the features which is not present in 1, present in 2 and present in 3. Okay, so once you have a clear idea of Hadoop 1, then we go for all those things. So this is the location where you can download Hadoop. After downloading and configuring, you need to populate 7 configuration files for Hadoop 1.0. There are 7 configuration files. For Hadoop 2.x, there are around 9 configuration files. What are those files? So, in this file alone will decide whether this computer is going to act as a master or slave. We have the first file, Hadoop -environment.sh. This file containing the Java's code path where you have configured Java. Being Hadoop is written using Java as your programming language, you need a Hadoop -environment.sh file where your Java is mandatory for Hadoop. If you are going to work with Hadoop, you should install Java. And the installed location need to be specified to the Hadoop through this file, Hadoop-environment.sh. The next file, core-site.xml. mapret-site.xml. HDFS-site.xml. So in core-site, you need to specify the name node computer's IP address. So which computer that you are going to designate as a name node, that computer's IP address need to be specified under core-site.xml. Please make a note. So if you are having 3 computers, example, one with IP 192.100.10.1, another 10.2, another 10.3. If you want to fix this computer as a name node, means here you open this core-site and you type 192.100.10.1. Now that computer will act as a name node. If you want this computer to act as a name node, instead of 10.1, if you specify 10.3, and third computer will act as a name node. Okay, all the installation process, all the software are same, but based upon this parameter value, the computer will be made to act as a name node or other. Okay, next mapper-site.xml. In mapper-site.xml, what you need to do here is you want to specify the IP address of your job track. This computer that you are going to designate as a job tracker, the computer's IP address needs to be specified. In HDFS-site.xml, you want to specify the number of replicas, block replicas. So you want to specify how many replicas that you need to have for your Hadoop cluster. Whether it is 1 or 2 or 3. Okay, you need to specify under HDFS-site.xml. And you have other files. Apart from this, let me arrange this. Step 1. HDFS-, MapRed, core-, next we have masters. And you have another file called slaves. In master file, you want to specify the secondary name node's IP address. And in slaves file, you want to specify all data nodes IP address. What are the data nodes that is going to be placed in Hadoop cluster? That data nodes IP address need to be placed under the slaves. These are all the 6 files. Apart from that, you have another file called this bash house. Bash run control script. Here you want to specify 3 things. One is Java's home path, where you have installed Java. Second, you want to specify Hadoop's home path, where you have installed Hadoop. Third, you want to specify the class path for both Java and Hadoop. It is nothing but you want to specify the location of bin folder. For Java and Hadoop, you have a bin folder. You want to specify the location of bin folder under the following path. So these are all the files. Kindly make a note of the files. In for administrator, this question has been asked repeatedly. Just make a note. So that we may have a glance of what information is present there. Configured with the username Hadoop and a password Hadoop. Password is Hadoop. And it will take me to the graphical user mode. Okay, so this is the browser. You can find okay, I think so it is now visible. Okay. Now you can find Hadoop 2 has been configured. Okay, Apache and this machine is configured with Hadoop 2. Okay. So you can find this configuration Hadoop 2.7.3. You can find all these configuration files. Core-site.xml. Okay, core-site.xml. Right click, open with gedit. Here you can find these are all the properties that you need to look up. These are all the properties. Okay. So here you want to specify this location file system.default name. Since it is a single node, you have specified as local port. Okay, what you need to do here, you want to specify the IP address of the computer that you are going to designate as name node. Imagine that you are having a computer name node with IP address 192.100.10.1 instance. This local host need to be replaced with this IP address. Okay, this corresponds to your port number. You are aware of the concept of port. Okay, if not, I will share you some video or IP addressing and port number for your reference. You can work with that. Okay, this is the file, the core-site.xml file. Okay, it contains the name nodes IP. You don't need to bother about this thing. What you need to do, you want to do this configuration to configuration pasting alone. I will share you the corresponding documents to you. I will just today's session. I am going to. You will have a separate lab session. Okay, I will practically and the video will be shared to you. You can work with the video and also I will share you the document. Using the document, you need to configure by yourself. The second thing, this is the information associated with core-site. In Hadoop-environment stage, what we specify? In Hadoop-environment stage, you want to specify the Java home path. Okay, here is the Java home path. You can find Java home path. Export Java underscore home equal to the location where we have installed Java. This line alone that you need to type. These are all predefined. You don't need to bother about this. There are a lot of lines. So that is come pre-installed. Here you need to specify only this line only. Java's home path. Next, we are going to open hdfs-site.xml. Right click. Here hdfs-site.xml, what you need to specify, this property alone that you need to specify. This property alone that you need to specify. Okay. The property you can find DFS dot replication, the value need to be 1. So because since it is a single node cluster, so here we are having only one computer. Another computer we are going to configure name node, secondary name node, job tracker, and all the associated things. We are going to configure all the associated things on the same computer, job tracker, data node, and task tracker. So this computer can be addressed using a local port, being it is a single node. Okay, so there is you can assign an IP address. What is the default replication? The default replication is 3. But if you have only one data node, it is not possible to have these 3 blocks. Therefore, you want to specify the value 1 here to override the default replication. DFS replication 1. So I will let you know this thing separately. These are all directories for name node. Okay. So I will let you know the information that you need to specify here is the replica. Here the number of replica is 1 here. Next slide. DFS application is 1. Next slide. Now mapper-type.exam. You have to specify the mapper.jobtracker IP address at the location. Being it is a single node cluster, you specify it as a local host. So if it is a multi-node cluster, you have to specify the corresponding IP address. Okay. So please make a note. A single node cluster, you can have a local host or IP address. If it is a multi-node cluster, for example, this is a name node with the IP address 192.100.1. This is your job tracker with IP address 192.100.10.2 instance. You want to specify instead of local host, this IP address needs to be specified. Okay, so these are all the things. Here, this corresponds to the second part. MapReduce.framework.name equal to yarn, which is a Hadoop 2.x parameter. We simply forget now. We are now discussing 1.x. Therefore, you need to worry about that. What you need to specify? Only this part, starting from configuration up to MapReduce.jobtracker's IP address alone needs to be specified. Now, we have noted down almost all files. Hadoop environment, core hyphen, maplet, HDFS hyphen, and everything is proper. Now the another file is .basrc. Where the file will be? The .basrc file will be under the home path. Under the home path, you can find the basrc file. .basrc. Being it is a hidden file, you want to open .basrc by typing control-H. During your installation, it will be very clear. Our next class will be installation class. Before going into installation, you just please come up with the following skills. That is .basrc. Under the home path, you want to search for the basrc. Here, .basrc. Right click, open with gedit. Here you want to specify all the things. Hadoop home path. Okay. Here is the first line. Hadoop home path where you have installed Hadoop. Next, you want to specify Java's home path where you have installed Java. And you want to specify the class path. Okay, for this Hadoop and for Java, you want to specify the class path. This is the class path. Okay, the bin folder of Java and bin folder of Hadoop need to be specified. These are all the three. So you don't need to worry about this thing. These are all by default. I have, since this cluster is configured with all. So Hadoop, Zookeeper, everything is configured. It has a list of lot of lines. Then you need to specify that this line only. From Hadoop, and similarly Java home. Export Java underscore home. And next one, class path. The path with let you specify the bin folder of Java and bin folder of Hadoop. That is sufficient enough. Okay. These are all the three entries that you need to place in the file. Okay. So after that, what you need, we have configuration. We have configured each and everything. After that, for the first time alone, you need to format. So step 7. You need to issue this format command for the first time. You have to format the Hadoop cluster. After formatting the Hadoop cluster, you need to start the service. Start -all. Start sh. Will start name node. Will start secondary name node. Will start job tracker all. And after that, if everything is perfect, if you type JPS, JPS stands for Java Process State. It will list all the entries. So these are all the ways by which you need to configure a Hadoop cluster. Very simple. So even though it seems as if a lot of complicated procedure, I assure you that you can able to configure your cluster within the maximum of 1 hour for the first time. We will do the same thing in cloud also. I will let you know how to configure the cluster by getting the resource from cloud. If it is cloud, we can able to configure a cluster within 15 minutes. Okay. Okay. Let me start this installation using this Amazon. Okay. I will connect to now the installation part what we have discussed theoretically. So we can do it using this VMware or we can do using Amazon. Okay. So I think so you people are aware of the Linux stuff. If not, we want to go through the Linux. Okay. So yes, do you have aware on Linux stuff? Sundar?
Yes, yes.
Yes. Jayanti, Archana, basic Linux. How to create, what are all the things that we have discussed? Creating a file, using this command, I think.
No, Raman sir.
No, you won't have
I'm experienced in Unix, but not in Linux, so it should be same.
but
I can pick up.
okay, so more or less the basic commands associated with the configuration.
Yes.
If not else, I will let you know. Okay, if you have any doubt, please stop at that instance. I will let you know during installation. Okay.
Okay.
What I am going to do, I am going to do the installation using cloud. I will show you both the thing. Okay. So.
Raman sir, before you install cloud, I have a couple of questions.
Yeah.
So when we are choosing the operating system,
Okay.
Now from a learning purpose, Ubuntu is fine. Generally, for commercial,
Yeah.
I mean the organizations use Red Hat, right?
Yeah.
Any specific reason, sir?
No, Red Hat is having support. That's all. So this Ubuntu, this Fedora, here these are all open source community. So here, if you get stuck with anything, you need to go for from the community only. Whereas the Red Hat, you
so that
can
is
get a paid version, support version.
okay. That is the only
That is
reason.
the
Okay.
main reason, intention behind going for Red Hat. Also, in terms of all other features, here they may have some little bit more services associated with to make the maintenance of the environment in an easy manner. That's all. Main concern is support.
Support. Okay.
If you have
Got it. Because
have confidence in you. Without the support, I can make it instance. You can opt for anything. This distribution distribution provide a perfect support. That's
okay. Another question I have, sir.
yes.
Generally, RAM is more required on the
Name node.
worker nodes.
Name node.
Name node or worker?
Yeah, worker node.
Because,
That is the concept of Spark. So if you are talking about Spark, the architecture itself will differ. Okay, we are now talking about this Hadoop. Hadoop and Spark are different things. Is it making sense? Yes. So here,
yeah. If it is map reduced, then if it is only map reduced, then we should use more RAM on name node.
Yeah, definitely. Usually name node, whether it is Hadoop, you are using this Hadoop as a framework, or you are using a Spark as a framework, the name node should have enough RAM memory. Also, because all the metadata informations will be managed under the name node's RAM memory only. That is the reason.
But metadata is not a big volume, no, sir. The whole load is picked up by worker nodes, right?
No.
The most of the load.
That is.
The compute will happen on the worker node, right?
The thing is that if you are having a 1,000 node cluster, and if you are having around 10 TB of data here, which has been split across 100 files, here what are all contents that need to be managed? For example, for a single file, you want to manage the above set. Okay, you want to manage the file name. You want to manage the owner of the file and the date and time of creation of the file and the access permissions for all other users who can able to read, who can able to execute, like all access permissions. The most important thing, number of blocks associated with the files. Okay, I had already discussed about the concept of blocks in our previous class itself, is it? So, 192 MB file with a default block size of 64 MB divided into 3 blocks, block B1, block B2 and block B3. Here these blocks will be distributed across multiple data nodes. We have n number of data nodes. Data node 1, data node 2, up to n. Am I audible?
But still, we are not able to hear Raman.
Yes, yes. My internet connection was disconnected. I now switched over my connection to my hotspot.
Okay, sir.
Okay.
Yes.
Sorry, sir. I missed some part here. Metadata you mentioned, and after that, the nodes I missed.
Yeah. The metadata information that need to be managed in the RAM contains the following thing. Okay. So here in a Hadoop cluster, you want to maintain around thousands and thousands of files related information like the file name, owner, date and time of creation, access permission,
of those files, read, write access, execute access permissions, a number of blocks. Here, this is the key thing here. For example, if you assume that a file of size, file 1 of size of 192 MB divided into the default block size of 64 MB, we have 3 blocks. And these 3 blocks need to be distributed across multiple data nodes. Those sort of information, number of blocks, the location of the blocks, where the blocks has been stored, location of blocks. So all the characteristics associated, block, whether it is a corrupted block, whether the block is corrupted or whether the block is correct, under replicated blocks, over replicated blocks. We have discussed about what is under replication in our previous session. Under replica,
Yes, yes.
over replicated blocks, missing blocks, corrupted blocks. Okay, all those sort of information you need to manage. So also you want to maintain about the information about these data nodes, which data nodes are live, which data nodes are not live. Okay, if the data node is facing any problem, like all other information, everything need to be maintained by the name nodes main memory. Here the name node maintain all the information only in the RAM memory. Imagine if you have a cluster of 1,100 data nodes or 1,000 data nodes with hundreds, thousands of files whose size is around 10 TB. Let me make it. How much of RAM capacity that you need to maintain all those data? So, whether you are using Hadoop or whether you are using Spark. So, what is Spark? Spark is a replacement to Hadoop framework. That's all. Okay. Where a cluster may say, you may have the same thing. You may have your data stored in the Hadoop cluster. You make use of this Apache Spark framework to do the processing. The main difference between going up with the Hadoop and Spark is that so Hadoop support only the MapReduce programming only, whereas Apache Spark support multi-tenancy support. We will have a separate discussion. Just I am letting you know, multi-tenancy means it can able to handle multiple types of applications, MapReduce applications, real-time applications, streaming data applications, graphical applications, like different types of applications can run concurrently on top of the data stored in those nodes. Here, if you are using Hadoop, you call it as a data node. If you are using Spark, you call this as a worker node. Okay. If you are using Hadoop, you call it as a data node. If you are replacing a Hadoop framework, you call this data node as a worker node. Here in this case, if we are using Hadoop or Spark, doesn't matter, your name node should have more memory. For Hadoop, the data node need not to have more memory. Why so? Because the data has been splitted across all the data nodes and the processing will be done here. Okay. What are all the RAM? The basic in real-time scenarios, how much of RAM is recommended for data node is, you may have a RAM of 32 MB. Okay, even 16 MB of RAM is a minimum size. It is a better choice to go up to 32 MB of RAM in your data nodes. But if it is a worker node, you need to have more than 32. So you may have a 64 or 128 MB of RAM. Why so? Because all the intermediate data, doing this data processing, all the data, if it is Hadoop, will be stored in the hard disk only, intermediate data. While performing this map and reduce, we have mapper, shuffler, sorter, combiner, partitioner. These are all the various phases of activities that happens in the map reduce program. So during this activity, all the intermediate data will be stored only on the hard disk. So here we perform a HDFS read and write. So only a minimum amount of data will be stored. That is needed for that current line of execution alone will be stored in the RAM memory of the data. All the data will be stored on the hard disk only. That is the way by which the Hadoop is architected. So as a reason, your data node need not to have more RAM memory. Okay, that's the first thing that you need to aware of. Whereas in Spark, Apache Spark, here it is a in-memory data processing. We call Apache Spark as a in-memory data processing. What is in-memory data processing? Here, instead of performing the reading and writing activity in the hard disk, all the intermediate data will be placed in the RAM memory only. What are all the data that you are processing with this worker node will be placed in the RAM memory, not on the actually hard disk. Initially, it will be in the hard disk. Okay. Well, once the process has been started, it will take from the hard disk and it will be placed in the RAM. Because of that only, your worker node need to have more RAM memory. If you are having Spark, both your name node as well as data node need to have more RAM memory. Also because all the process will take place only in the RAM memory in the worker node. But in case of Hadoop, your name node alone need to have more memory, RAM memory compared to that of data node. Also because all the intermediate data will be stored in a hard disk only, not on the RAM memory. Okay, we will have an in-depth discussion regarding this while our Hadoop has been over and we are going with Spark. I will let you know all those things. So normally,
Yeah. Raman sir, some of the thoughts are clarified now. That's very good.
yeah,
So so basically I'm trying to, just confirm this. If it's a data node,
yeah,
which is a Hadoop architecture,
yeah,
then we should use more cores, and the RAM is not very important, right?
yeah,
More cores
yeah,
because it runs on the
yes,
disk, right?
yes,
If it is a worker node, then both core as well as RAM is important because it's a Spark architecture, in-memory architecture.
100% exactly correct. You have kind of grasped the correct thing. Thanks for your grasp.
Okay,
Also because
thank you.
data, also
Mm.
the processing both take place in worker mode, but at the same time, your data will be processed by keeping it in the RAM memory only. That is the reason.
Okay. So whenever this name node, in continuation to that, whenever this name node is up and running, so it will take all the metadata information into RAM for speed, right? Is that correct, sir?
Yes, sir. Please repeat your question.
Yeah. Whenever the name node is, spin up, started,
Yeah.
so it will take all the metadata information into RAM.
Yes, definitely. When you start the name node will load all the metadata into the RAM memory. By keeping those information in the RAM memory, what are all the requests that it is receiving from all other computers, such as a secondary name node, job tracker, data node, task tracker. So everything need to be serviced immediately. So whenever a request is raised from a particular computer, name node immediately looks into the metadata that it is managed in the RAM and immediately it can give back the response back. If not, if the
Okay.
name node is architected in such a manner that the information managed in the hard disk, then hard disk being an electromechanical device, there will be a delay, a seek delay and a rotational delay like this. So if n number of requests is coming from the underlying data nodes of the cluster, the name node will feel a little bit difficulty in giving the response in a right time. It took some time to look for the response by loading the data from the hard disk into the RAM memory. After that only it can able to provide back the needed result to the requested clients. That's the reason why all the information is managed in the RAM memory. Yes?
Yeah. So some of my gaps, it's clearly clarified, sir. Thank you very much.
Okay.
I have one more question.
Yes, please. You should
Uh,
not worry about asking.
yeah. Generally, Hadoop, we consider as an important piece. One is cost, and because it's cheaper, open source, and all. And another reason is it can also handle unstructured data.
Yeah, definitely.
So, yeah, compared to RDBMS appliances or anything like Teradata or anything.
Yeah.
So, is there any other system other than Hadoop which can handle unstructured data, or this is the only system?
As of now, you have Hadoop, Spark, Flink. These are all the variant of Hadoop. That's all.
Yeah, only Hadoop ecosystem, or is there any other ecosystem outside Hadoop?
Data appliances also handle unstructured and semi-structured data, like Teradata, metadata, the current versions. But the thing is that you need to invest a lot. Being the particular appliances, you need to invest in terms of lakhs to establish the infra, to procure the hardware itself. Also, all the associated softwares are license-based softwares. Okay, that's the reason why
Right.
it's not at all recommended. Why is it? Because being these things are open source and we can make use of community hardware. Also, being it is adapted to the concept of this parallel processing, the Hadoop was found to be more than 100 times fast compared to that of your data appliances.
Right. Yes. Appliance is definitely very expensive.
Yeah, these are all the advantages. Your appliances also support what we call as big data, but with huge cost. That industry want to invest for.
Right, sir. Thank you. Those are my questions, sir.
Okay, so to handle this data, which is semi-structured and unstructured, we need to make us use of these tools like Hive, Big, etc., etc. That time that you will know how to handle different types of data, how to handle unstructured data, how to handle server logs, how to handle images, everything that I will let you know. So for handling images and etc., we go for this machine learning related stuff. We got different frameworks like TensorFlow. Okay, so those flow frameworks will have some inbuilt functionalities. Usually, we make use of Python language or handling image processing like things. Okay, I will share those information also. Yes, any other doubt? Jayanti, ma'am, Archana, ma'am, is it clear what we have discussed so far?
Yes, sir.
Yeah, yes. If you have any doubt, please don't hesitate in asking your question. Okay. So what are all the things theoretically that has been discussed? I am going to show you an installation by taking instance from cloud. No need to bother about that. We have a separate session on cloud. Okay. So today I will share you how to install in cloud. Tomorrow we will look those information how to install using this virtualization software. Okay. Before going into that, we need to have some discussion on this virtualization software. After then, if we go for installation, it will be good. So for that, minimum we need 2 hours to 2.5 hours. So we can make it today by using Amazon Cloud. Now I am connecting with my cloud account www.amazon.com. This is my credentials. You want to get a credential? If you have a credit card, you can make an account with Amazon. I am going to create a computer. That's all. I am going to create a computer. Instead of a physical computer, I am going to create a computer. Okay, this thing will be taught separately. You no need to worry about. Just I am moving straight away. What I need. I am going to create a computer. Here, these are all computers. Running instances was found to be 0. What I am going to do, I am going to create a Ubuntu computer for our practice. Launch an instance. Okay, I want to choose Ubuntu server as my operating system. Review and launch my cluster. Okay, my password key is -6. I acknowledge. Okay, my instance got launched. That's all. You just find how easy it is to launch a Ubuntu machine. Okay, so if you go up launching with the physical, if you want to configure, it took a minimum of 1 hour to launch. Okay, here it will be launched within 3 minutes. Let me make it as a Hadoop single. Let me wait for 2 to 3 minutes so that it launches within 2 minutes. Please wait, I will be back. I am not having my mouse with me. Please wait a while. Okay, my machine is ready now. You can find it is in running state. Okay, so now I am going to connect. So we have a separate class for cloud. So at that time you know how to launch, what are all the steps that need to follow. Now I am launching a machine for my practice. That's all. So host name, paste, SSH, authentication, browse, desktop, open. Yes, the default username is open. Good. Settings, appearance, board. Yes, is it now? I think so. We can able to view it clearly. Now, what I did, I created a machine. I created a machine here. Okay. So here I am going to do the activity that it is listed. First step, what I did, what we need to do here. So step one. So you want to create a machine computer with your Ubuntu operating system. Next, what we need to do, you want to install Java. Next, you want to install SSH -server. We have already discussed. We need to install SSH -client. Next step, we need to create a password. SSH -key generation. We want to generate the password. We have a ID underscore RSA.com and we have another password ID. Okay, underscore RSA. We will have a discussion on this password. SSH generation, and you want to create a file by name authorized underscore keys file to make you authorized user. Okay, then step 6, you want to download and install Hadoop. Step 7, after installing, you need to populate the configuration files. We have discussed about 7 configuration files. Core-site mapper, you want to populate. And first time only you need to format and you need to start all the services. Okay, you want to start all the services. Here we are going to make all the node, name node, secondary name node, job tracker, data node and task tracker as a service. We want to start all the services. And if you type finally, if you type JPS stands for Java Process State. If everything is perfect, it will list all the services. Okay, these are all the things that we are going to do now. We just make a note of this. We have already discussed somewhat in our initial hours. Okay, in today's session. So first step, what I am going to do before going for any update. Okay, I need to make an update. Sudo apt-get update. This is the first command that I need to type for. These are all Linux commands. If you don't know Linux, you don't need to bother. We have a class. Okay, separate session. Now I am going to install. I have performed update Java. Sudo apt-get install open jdk-8-jdk. So I am installing Java JDK 1.8 version. Just look how fast that it is installed. Am I audible? Sundar sir, Jayanti ma'am, Archana ma'am. Yeah.
Yes, sir, you're audible.
Yes, sir. Yes, sir, you're audible.
Here the power was down, so I am connecting with my laptop onto
Using a hotspot.
mobile only. Yeah, hotspot. Okay, now.
Okay.
So here we have Java configure. Next step, what I need to do, we have install Java. Next we want to install SSH server. Sudo apt-get. I will share you the document. Okay, install open SSH-server. Okay, we have already open SSH there. So then we want to generate a key. Here you want to be careful. You should not use this sudo privilege. Just simply SSH-keygen. SSH-keygen. So you can find it generates a key under the following path. Home under Ubuntu. Ubuntu is the username. .ssh is the folder. ID underscore RSA dot is the key. Simply type enter. That's our passphrase. Everything that key is generated here. You want to type everything enter. Now you can find under the location. Now currently you are under home Ubuntu. Here under home Ubuntu you have a .ssh folder. For that ls-al, this command will reveal you the folder .ssh folder. Being it is a hidden folder, if you simply type ls, it won't list. If you type ls-l attribute file, A stands for attribute file, it will list now. So you can find cd.ssh under which you can find. If you type ls, you can find these two keys. Okay, ID underscore pub, ID underscore authorized. 3 keys have been generated. What I need to do here, I want to copy this. Okay, I want to the key that I have generated. Currently, present working directory. I am under home Ubuntu. So I need to copy. The command is scp. Okay, under home, under Ubuntu. Under Ubuntu, we have .ssh folder. .ssh folder, under which we have id underscore rsa.pub key. You want to copy under that name. Okay, /home /ubuntu /ssh. You want to specify the name. Authorized RIZTD authorized underscore keys. Okay, yes, perfect. Also because then only you will be recognized as the authorized user. Okay, so then you will be authorized underscore keys. Now you can verify SSH localhost. If everything is perfect, you should be able to connect. Yes, without asking password. Yes, perfect. Now you got connected. So without asking password. Yes. Now you want to download and install Hadoop. Okay, we did all the thing. So we have installed the Java. Okay, we have installed this SSH server. Okay, we have generated the key, these two keys, and we have created authorized. We need to download and install Hadoop now. Where to download? Go to Google and simply type hello. சொல்லுங்க. உங்களுக்கு எத்தனை மணிக்கு செஷன் இன்னைக்கு? நீங்க ஓகே ஓகே சரி, நீங்க கனெக்ட் பண்ணுங்க. சரி 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 சரி. நீ இப்ப இங்க எங்க விருதுநகர் போயிட்டு இருக்கீங்களா? அங்க இருந்து வெறும் 20 நிமிஷம் இருப்பேன். சரி சரி, நான் மதுரை தான். இப்போ ஒரு கிளாஸ்ல தான் இருக்கேன், பிக் டேட்டா கிளாஸ். இது முடியறதுக்கு அது 10 மணிக்கு தான் ஆரம்பிக்கும். 10 காலம் ஆகும், ஒன்றும் பிரச்சனை இல்லை. நீங்க ஏர்போர்ட்டை தாண்டிட்டீங்கன்னா 20 நிமிஷத்துல வருங்க. 20 நிமிஷம் தான். சரி சரி, ஒன்றும் அவசரம் இல்லை, நீங்க ஜாயின் பண்ணுங்க 10 மணிக்கு. ஓகே.
Okay, now, so it is frequently causing a network problem. Sir, is it okay now? Hi, sir, am I audible? Yeah, yes, good.
Yes, sir.
Yes, sir.
Now we want to download this Hadoop. Simply go to Google and download Hadoop. So it will give you the list of pages, Apache Hadoop releases. Click on Apache Hadoop releases. So go to the mirror site. These are all the current versions. The current version is 3. It is okay, released on 13 December 2017. We are going for Hadoop 1.x. Click on the mirror site. Go to any mirror site. Here you can find Hadoop 1.2. Click on Hadoop 1.2.1. Here the file that you need is this file, Hadoop-1.2.1 tar.gz. This is the file that you need to have. Okay, this bigdata.gz is a source code file. If you are going to do any modification on the source code, you can download the file and do the modification. So here this is the Hadoop file. Simply right click, copy link address, to paste, then come to the machine, come to your machine. The command is wget. Okay, right click, the address will be pasted. Now your Hadoop will be downloaded. Now you can find the Hadoop is wget stands for webget. To download a file from a particular server, you can make use of this wget command. Now if you type ls, now you can find Hadoop-1.tar.js. You want to untar it, type tar-svf, you specify this Hadoop. Now it will be untar. Once it is untarred, you have the conf folder. Okay, you have the conf folder. Now you list, you can find you have a Hadoop 1.2.1. This is the untarred folder. Now if you type ls here, you can find a conf folder, bin folder, all the associated things. Go to the conf folder. Here you can find all the associated files. Okay, the file that we have mapred-site. Okay, core-site.xml, hdfs-site, masters, slaves, everything. Hadoop-environment.x, it will have everything. Okay, what you need to do now, you want to populate those files. Okay, you want to populate those files. So please wait a while. I will take some documents.
Sir, you will share these detailed documents, right?
Everything. No need to worry about it. I will share everything.
Yeah, all it.
This is the document that I am going to share. What are all the things that we did has been documented. Okay, so we have executed apt-update, get install OpenSSH server, key generation, and simply we have generated authorize underscore keys. We have verified, we have installed Java. Okay, so here we have untar. Then we want to type it in the .basrc file, home Hadoop, the path, the Java. Here what you need to specify, the Java version 8 we have downloaded. Okay, Hadoop underscore home. Instead of Hadoop, what you need to here we have Ubuntu. That's all. The username is Ubuntu. Here export Hadoop pass Hadoop underscore home.bin. User lib JVM Java open. Okay. So first these are all the three things that you want to specify in .basrc. Then after that, okay, so you have Hadoop-environment.sh and the Hadoop environment.sh. So here export Java underscore home user lib JVM Java -8 OpenJDK -AMD64. Similarly for core-site
instead of Hadoop, here we have a user by name Ubuntu. Okay, I am replacing this document by Ubuntu. So here, if you are going tomorrow's session, you are going to install in VMware using the same user. Okay, Hadoop user or Ubuntu, it is your choice. Here, core site, I want to specify this. And the site 2 properties, one is the local host name nodes IP address, the map run, HDFS, all other things are same. Okay. So now let I open this first file, core-site.xml. Okay. I want to Hadoop environment.sh. Simply right click, copy the file, go to the server, under configuration. Now you can find. So you have a first file, Hadoop environment.sh. Let I open the file, sudo vi Hadoop environment.sh. Okay. So move to the location where you want to install. So let I install here. Insert. Simply right click. Okay. Now Java home. Escape :wq. Now the first file has been okay. Next, what I need to do, sudo vi. I want to specify core-site.xml, the second file. Okay. So you want to move to the configuration tab. Under the configuration tab, you can paste what I have specified. Here you want to specify the following two things. One temporary directory under home Ubuntu temp data by name. Okay, we have discussed all the things theoretically. Right click, copy, go to the location, simply paste. That's all. Escape :wq. Now core-site is over. Sudo vi mapred-site.xml. Okay, this is the third file, mapred-site.xml. Move to the location here, under configuration, press insert. Here under mapred-site.xml, what you need to do, you want to specify the following thing: the property mapred job tracker and the corresponding local host. Okay, right click, copy, go here and simply paste. That's all. Escape :wq. Now you have mapred core-site, mapred-site, hdfs-site. Sudo vi hdfs-site.xml. So move to the location between this open and close configuration tab. Under hdfs-site.xml, you want to specify this replication, all other things will have an in-depth discussion. Okay. Copy. Simply right click. My God. Escape :q exclamation. I wrongly copied. Okay. We have hdfs-site.xml. Move to the location. Insert. Right click. Okay. The property DFS application. Yes, good. Escape :wq. Now you have everything perfect. Hadoop core mapred vs hdfs site, and we have masters also slave. We have sudo mi masters file. Okay, you can find here you have a local host. What you need to do, you want to move backward to come to your .basrc. Okay, here present working directory under Ubuntu you have this .basrc file. So if you type simply ls, it won't list anything. If you type simply ls-l, you can find .basrc. Under basrc, you want to specify three things: Hadoop home path, MapReduce home path, Hadoop home path, Java home path, and class path. Sudo vi dot basrc. Basrc stands for bash run control script. Open this, move to the last line. Okay, here you can insert the following thing. Where you have under basrc, you want to specify three things. Okay, under home Ubuntu, you have Hadoop. export paths equal to $path colon Hadoop Hadoop underscore home slash bin the bin folder. Similarly, use Java shell location. Copy and click. Okay. Yes, you have everything. Now, now you want to create a folder. Oh, so because you have specified that you are having a folder under core-5.xml, you can find you have specified a folder data. You want to create a folder here under home Ubuntu. You are now currently under present home under Ubuntu. Make directory dump data. That's all. Okay, everything is perfect. The command source dot bash rc. Java -8 OpenJDK I am okay. Let me check it. So we don't have that. Okay, cd user lib jvm. Okay, ls. Here you found the Java -8 OpenJDK -AMD64. What is the cd Java -8 OpenJDK AMD64. Here you have this bin folder, cd bin. Under which you have all these things. Okay, it is perfect. What is the reason? So let me check now. Export Java underscore user lib jvm OpenJDK. You please help me whether we have any errors here. Java underscore home user lib jvm. Yeah, yes, we have a space left out. Please look into this. We have a space here. That is the issue. Open bash rc file. Okay, so cd data cd space data. We have left out the space. That is the reason. cd slash home slash Ubuntu. Then you have this bash rc file sudo v8 dot bash rc. Okay, in bash rc, what we did is we did an error by leaving space in the Java's path. Now we can find you have a typed a space here. Now delete the space. Java -8 OpenJDK -AMD64 escape colon w. Yes, perfect. Now if you type source rc source dot bash rc, it will work fine. Yes, good. Okay, everything is perfect now. We did all the thing. For the first time, we need to do the format. Okay, the command is bin slash Hadoop space name node space hyphen format. Okay, so you want to get the message has been successfully formatted. So it is perfect now. Now if you type JPS, it shows nothing. Now let me start the service. Bin slash start hyphen all dot sh. It will start all the services. Name node, data node, secondary name node, job tracker, and task tracker. Now if you type JPS, now we can find all the services are running. This is the way by which you need to install and configure a Hadoop system. Is it making sense? Is it clear? How easy is it? I have another session at a cloud session. Okay. So thanks a lot. We meet again on tomorrow. I will share you the bank details. Kindly transfer the fee by tomorrow.
Okay. Thank you very much.
Thank you very much.
Thank you, sir.
Thank you.